Hi everyone. We have a problem today, a very interesting problem from Indian IIT JEE, Joint Entrance Examination for Engineering Schools in 2020. So here's the problem in which it's not clear how to proceed actually, because let's draw a picture, and so here is a tunnel, and here is a train that going in the tunnel with certain speed with respect to ground. So there is a frame here. So this train is, so let's call it frame 1. With respect to that, this has speed vt going that way. So over here the air is not moving. The air is 0 here, but over here you can see this, all of this air has to move past it. So somehow the air is kind of going to go with some speed here, and v air, let's call it prime, v air position 1 and position 2, instead of prime, let's call it 2, let's call it 1. Okay. we would like to actually convert this so that this problem in a flow of air problem. So if you look at this problem from something train frame, so this is the train frame, and this is the ground frame. In the train frame, suddenly this guy starts to move with speed vt here, and over here we don't know the speed because we don't know the pressure, so etc. So this is like a chicken egg problem here. You can't use a mechanical adding this vt to that. We'll just say the velocity is v, and we're gonna apply they have given this condition that is steady, right? It's steady and laminar. So why have they given that condition? Steady and laminar will for us this condition will say it means I kind of use a1 v1 equals to a2 v2 for flow, and then use Bernoulli. Okay, so now we have, as if the train is in this frame, train is going nowhere, and the air, all this air is kind of going like that. So it's kind of train in the way, an obstacle, and so it is flowing in very steadily. Okay, so with that, it says this this here area of crossing inside a tunnel is S0. This area here is ST, and this area here is 3ST. So that S0 is 4ST. So this is the area at 1, this area at 0, this is 0.1, 0.2, this area at 0.2, and this is area at 0.1. A very important point here is we can, the center of mass where is here and center of mass just a little bit below here, right? But we can just ignore gravity, so we can say approximately same height, and we ignore rho gh. Or rho gh1 is equal to rho gh2. You can just say that. Okay, so now we have one equation, this a1. So a1 is s0, v1 is v train, a2 is so 3st, and st is equals to 1 over 4 s0, so 1 over 3 over 4 s0 area, and then v. That's how you get the v instead of adding mechanics wise. Okay, so v at the 2 point, v at the 2 point is equal to 4/3 v trend. Now this makes sense. 4/3 makes sense because this will be a lower pressure here, and this will be higher pressure here, and so lower pressure here because moving. So I would expect moving faster, right? Bernoulli principle. And so using this, I get rho p at, so p at 2 plus half rho v2 square equals to, of course, plus rho gh2 equals to p at 1 plus half rho v1 square plus rho gh1. Now we cancel these guys out, and this is set to be at atmospheric pressure 0, and this is supposed to be P in given over there. This V2 and V1 both in terms of Vt, and we're supposed to get P0 minus P. So P0 minus P, and so bring this on the other side and leave this here. Half rho is common to both of them, and then you have V2 square minus V1 square, and it's really not that difficult to get from now on. Vt square will be common, and the V2 square is 19 over 16 over 9 minus 1. So this factor is 7 over 9. So this n here is 9. That's the answer. Okay, this was a good problem. I'm gonna stop here. We'll try to do one problem at a time. You can check more problems out at www.physicsbootcamp.org. Subscribe to this channel if you haven't. And you can hit the like button if you like. Okay, stop. Bye.